In this project, we are exploring and analyzing two common bicycle crank designs. Bike cranks are essential in bikes and the forces are constantly applied on them. Therefore, having a bike crank that is durable and stable is essential for the safety of the rider. As shown in the figure on the right, two common designs are simple bar and curved bar design. The load approximately equal to 1,000 Newton. The loads are applied on the pedal arm as forces usually applied there to propel the bike. We also assume that the diamond-shaped hull are fixed supported.
Some operations are common and some are unexpected to ensure structure is stable. The configurations of the designs are very similar as demonstrated in the table. Based on identical parameters, the analyzation on stress and safety factors should be comparable. For the horizontal orientation, forces applied downward when the crank is horizontally oriented as shown in figures. This represents the case where the biker propels the bike forward. The maximum stress of the simple bar is noticeably higher than the curved bar. In addition, the location of maximum stresses are different. The simple bar design has the maximum stress located at one of the rounded edges in the fixed diamond-shaped hole, whereas the curved bar has the maximum stress where the cylinder shape and the arm shape intersects. The curved bar design has a factor of safety of 2.24. This means that the yielding stress is more than 2 times of the working stresses. Safety factor of 2 represents considerably stable system. On the other hand, the simple bar has a factor of safety of 1.932, which is lower than the curved bar, but still can withstand the working stress.
This is the first vertical case where the forces apply downward when the crank is downward vertically oriented. This represents that the biker is standing on the bike. The maximum stress location of the curved bar is identical, whereas the location of the maximum stress of the simple bar changes to the pedal arm. Moreover, the maximum stress of the simple bar design is even higher than the curved bar design compared to the horizontal case. The safety factor of the simple bar design plummeted from 1.9 in the horizontal case to 1.5 in this case, making it less stable. On the other hand, the safety factor of the curved bar design increased from 2.2 to 2.4, increasing its stability.
The unexpected diagonal load is applied 45 degrees upward towards the crank. This unexpected phenomenon can happen when the bike tips over due to strong wind, an accident, or a bad biker. The maximum stress locations are similar to the vertical orientation. The maximum stress of the simple bar design increased by about 20 megapascals, where the max stress of the curved bar design decreased slightly. From horizontal case to vertical case to now the unexpected diagonal case, the factor of safety for the simple bar design continues to decrease when the factor of safety of the curved bar design continues to increase. In another unexpected case, we apply the force normal to the arm pedal towards the crank. This can happen due to an accident or a person who stupidly stepped on his or her bike when it lays on the ground. The maximum stress nearly doubles for simple bar design to around 360 megapascals, and for the curved bar almost triples to 343 megapascals, comparing to the other unexpected case. The location of maximum stress for the simple bar design changes back to the location of maximum stress for the horizontal case. The massive increase of maximum stress results in a factor of safety lower than 1 for both cases. Force applied in normal direction can break a bike crank very easily.
From all the results above, we draw a conclusion that the curved design is way better than the simple bar design. The only advantage of the simple bar design is that it can be manufactured more easily due to the simple geometry.
We also found out that one should avoid normal force applied onto the pedal arm. To further improve the curved bar design, one can figure out a way to strengthen the intersection of the cylinder and the crank arm. Thank you for listening to our presentation. We hope you enjoy your bike rides.